Hi and welcome back to my channel, and this week's problem is the one you can see in front of you, and we've got to solve it to find A and B. Now pause the video if you want to have a go at solving this problem yourself, but I am going to go through and show you my solution. So the first thing, we've got two equations, we've got two unknowns, so we should be able to solve it. It shouldn't be too much of a problem. Usually what you would do with something like this, or just any simultaneous equations, is get one letter in terms of the other. But that's a little bit difficult here because of the powers. So what I did is I first noticed, which many of you probably will do if you're watching this video, that we've got a difference of two squares at the top with the a squared minus the b squared. So we can write that out like this: a plus b, a minus b is equal to 4. And then you can simplify that by writing it as a minus b times by a plus b all squared is equal to 4. That just makes things a little bit nicer, and it's something that intuitively I think you would probably think to do immediately. So I'm going to just replace my first equation with that because, like I say, that's a little bit nicer and should make it easier to deal with. Once I've done that, what I notice, if they both got a minus b in them, that's the kind of common factor. So what I could do is I could get either equation in terms of a minus b and have something else equal to that on the other side. So if I rearrange the first equation, I get this. So a minus b is equal to 4 divided by a plus b all squared. Now, I know I can divide by a plus b all squared because I know it can't be 0, because I've got that times a minus b, or that times anything, gives me 4, gives me a whole number. And so neither a plus b can be 0 or a minus b can be 0. In other words, they can't both be the same thing, or one cannot be the negative of the other. Okay, so once I've got this rearranged form, I'm then going to replace the a minus b in my second equation with this. So I'm going to get this: 4 over a plus b all squared times by a squared plus b squared is equal to 5 over 2. Now, what we need to start doing here is getting rid of any denominators that we can do. So I'm going to start by multiplying both sides by a plus b all squared. So we tidied it up a little bit. Next thing, I've got a bracket to deal with, and I've got that 5 over 2, so I want to cancel out that 2. But first, what I'm going to do is expand the bracket on the right-hand side. So that's going to give me this: 5 over 2 brackets a squared plus 2ab plus b squared. And then I'm going to multiply the both sides of the equation here by 2 to just cancel out that other fraction, like I said we needed to. So we get this: 8a squared plus 8b squared is equal to 5 lots of a squared plus 2ab plus b squared. And quite probably easily, quite straightforwardly, I'm just going to multiply 5 by everything. I'm going to expand the bracket next. So multiply out that bracket: 5a squared plus 10ab plus 5b squared is equal to 8a squared plus 8b squared. Okay, next step, obviously get everything onto one side, set it equal to 0. Now I've got this: 3a squared minus 10ab plus 3b squared is equal to 0. Now, you might know what to do next, you might not know. When I went to school, I don't know why I wasn't taught this method, but I know it now. So I know how to solve things like this. It's a method called exploding the middle or splitting the middle. Now, to do that, what I need is to multiply the coefficient of my a squared by the coefficient of my b squared. 3 times 3 is 9. So I'm looking for factors of 9 that add to make my middle coefficient, that minus 10, normally the middle one. So I need numbers that multiply to give 9 and add to give minus 10. It's pretty straightforward. It's going to be -1 and -9 that will work. So that means we split the middle term up into those coefficients. So we went from -10ab to -1ab and -9ab. Now the next step with exploding or splitting the middle is to factorise the first two terms here and then the third and fourth terms. So just looking at 3a squared minus ab, they've both got an a in them, so I'm going to factorise that out. And so I get a brackets 3a minus b, and I now know that that bracket must be the same in my third and fourth terms when I've done my factorisation. And if I go back, I need to have 3a minus b, and so to factorise that out, it's going to be minus 3b outside. Hopefully you can see how that would work. I'm flipping backwards and forwards between the two, just so hopefully, like I say, you can see it. Right, then what we do is we take that bracket and we factorise the bracket out of both terms, the first term and now a second term. So we're going to take 3a minus b and put that to the front, and then we're going to get left in the other bracket with a minus 3b. Okay, so we've got this. Now, anybody who's got any familiarity with equations, quadratic equations, will know the next step here. So either 3a minus b is equal to 0 or a minus 3b is equal to 0, because I've got something times something is 0. One of those two things will have to be 0. So like I say, either 3a minus b is 0 or a minus 3b equals 0. Now, in both these cases, we're going to rearrange and we get 3a is equal to b or a is equal to 3b. We've got two scenarios here. So we're going to deal with these like we would in any other type of maths. We're going to deal with one scenario first and look at what solutions that might give us, and then look at the other scenario and see what solutions that will give us. So first of all, we're going to consider a is equal to 3b. And if a is equal to 3b, we're going to substitute that into the first equation, and we're going to get this. 3b minus b times by 3b plus b all squared is equal to 4. We're going to simplify it naturally. So 2b times 4b all squared is equal to 4. We're going to square that bracket to give us 2b times 16b squared is equal to 4. And that will give us 32b cubed is equal to 4. Okay, divide by the 32, so we get b cubed is 1 over 8, and cube root that, we're going to get b is equal to a half. Now, we know in this case that a is equal to 3b, so times this by 3, and we get that a is equal to 3 over 2. Okay, so that works, or should work at least. We're going to check both solutions, or all the solutions at the end. But make sure you do check. We're going to tidy that up, put that all over to one side, and now we're going to consider the other scenario, and that is when b is equal to 3a. So if b is equal to 3a, again, I'm going to substitute this into my first equation. I'm going to get a minus 3a times a plus 3a all squared is equal to 4. And it's going to end up, because of the symmetry, which you may have noticed yourself, with a very similar simplification. So I'm going to get minus 2a times 4a all squared is equal to 4. I'm going to square the bracket again, so minus 2a times 16a squared is equal to 4. Fully simplifying it, giving me minus 32a cubed is equal to 4. Divide by negative 32, and we get a cubed is equal to negative an eighth. And then we're going to cube root that, and we're going to get a is equal to minus a half. And just like we did before, we know in this scenario b is equal to 3a. So if a is minus a half, b is 3 times that, b is going to be negative 3 over 2. Okay, so we've worked out both solutions, or all the solutions, with both scenarios there. So our final answers here are a is 3 over 2, b is a half. Or the other solution that would work is a is minus a half and b is minus 3 over 2. If you try this problem yourself, hopefully you were able to get the same solutions. If you did it in a different way, put it down in the comments below, because I'm always interested to hear, the other solutions that people have got, the other methods that people have used. Did you know about explode in the middle? Did you not? Did you use, like I say, something completely different? Let me know down in the comments. And I have done a video on explode in the middle, so I will link that somewhere over here if you're interested, and you can watch that one. Okay, thank you for watching the video, and I will see you next week for another Mr. Talbot Maths video. Till then, bye-bye.